As the name suggests, right triangle trigonometry deals with right triangles only. We'll talk about how to deal with other types of triangles in the future. With right triangle trigonometry, first of all, we need to know SOHCAHTOA. This is a memory device to help you remember the relationships within a triangle of each of these functions on this side over here. So this part right here tells you about the sine function. It means the sine of a triangle, of an angle I should say, and angles in right triangle trig are usually the theta sign. So sine of theta equals opposite over hypotenuse. And what this means is if we have a right triangle, like the one right here, and we are talking about this angle right here, the opposite of this angle is going to be this side. The hypotenuse is always going to be the side opposite of the right angle. And then we call this last side the adjacent side. Okay, this brings us to CAH. The cosine of theta is equal to adjacent over hypotenuse. And last but not least, the tangent of theta equals opposite over adjacent. So let's see what this looks like with an example. Let's say you have a right triangle. And I'm going to label the sides, let's see, 9, 12, 15. And we're going to use this angle right here as theta. And in this question, I'm going to ask you, find sine, cosine, and tangent of theta. When you write sine as a function, it's written as SIN, not pronounced sin, pronounced sine. So sine of theta, if you remember with our memory device, SOHCAHTOA, sine is opposite over hypotenuse. So we're going to look at sine. All right, here's our angle. And we want to know what number is opposite of sine. Well, it's going to be 9. It's going to be the leg that is not touching the angle there. So opposite is going to be 9. And then the hypotenuse here is 15. If you can simplify, please go ahead and do. So 9 over 15, the top and bottom can each be divided by 3. So this is 3 over 5 would be the sine of theta. Next, we're going to find the cosine of theta. And the way to write cosine as shorthand would be COS, not pronounced cos, but cosine. Cosine of theta is adjacent over hypotenuse. The adjacent side is the leg that is forming the angle, so 12 over the hypotenuse, which is 15. And again, if you can simplify, go ahead and do. Again, each of these sides can be divided by 3, so this is a 4 over 5. Finally is tangent of theta. And tangent is opposite over adjacent, which will be equal to, let's see, the opposite of theta is 9, and the adjacent of theta is 12. Divide each one by 3, so 3 over 4 would be the tangent of theta. And again, you do not pronounce this tan theta, it is tangent of theta. The last thing that I want to talk about with this basic right triangle trigonometry is even if you have, let's say, square root of something, like square root of 15, that's okay. You can have a square root of 15 in your answer, like for example, if that was the case, if this was square root of 15, then we'd have square root of 15 here. The only difference is that doesn't simplify to 3 over 5. So again, over square root of 15, that doesn't simplify, and the square root doesn't affect the tangent. So it's okay to have a square root there. It'll just be in your fraction. And usually the ACT doesn't ask you to get square roots out of the denominator, at least in tangent, in trigonometry. All right, that is basic right triangle trigonometry.